Summer of 1943, the jungles of Guadalcanal. A Type 97 Chiha medium tank sat disabled in a muddy clearing, its commander dead at his post. 30 yards away, an American M4 Sherman had stopped, its turret still smoking from recent firing. Japanese infantry who survived the engagement emerged cautiously from the tree line, examining both tanks. What confused them most was not that they had lost. They had grown accustomed to losing tank engagements against American armor. What disturbed them was the impossibility of what they had witnessed. Their tank commander had reported taking 5 hits in less than 20 seconds before his radio went silent. 5 75mm rounds. The Japanese tankers knew their own Type 90 artillery piece required nearly a minute to fire, reload, and fire again under combat conditions. They had assumed all 75mm guns operated similarly. The Americans had just demonstrated otherwise, and that revelation would haunt Japanese armor doctrine for the remainder of the war. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. For 3 years, Japanese tank crews had prepared to fight a war that no longer existed. Their training, their tactics, and their equipment were all predicated on assumptions about armored warfare that the Americans had rendered obsolete. The Type 97 Chiha, Japan's most common medium tank, mounted a 57mm gun that was already outdated by 1937 standards. Against Chinese forces in Manchuria, and later during the invasion of Southeast Asia, this had proven adequate. Chinese armies possessed limited anti-tank capabilities, and British forces in Malaya and Burma were similarly unprepared for tank warfare in jungle terrain. Japanese armor had rolled through these campaigns encountering minimal effective resistance. This success bred dangerous confidence. Japanese military planners had designed their armored forces primarily for infantry support rather than tank versus tank combat. The archipelago geography of the Pacific Theater seemed to validate this approach. Tanks would operate in jungle clearings, on narrow coastal roads, and across small Pacific islands where their primary mission would be supporting infantry assaults and defending against amphibious landings. The possibility of encountering large numbers of enemy tanks seemed remote. American armor doctrine had evolved differently. United States tank development drew heavily from observations of German armored operations in Europe. The fall of France in 1940 demonstrated what concentrated armor could achieve when properly employed. American planners recognized that future wars would require tanks capable of both infantry support and sustained combat against enemy armor. This dual requirement shaped every aspect of M4 Sherman design. The Sherman's development began in 1941 under emergency conditions. German armies were overrunning Europe, and America's existing tank designs were inadequate. The M3 Grant and Lee medium tanks rushed into production as stopgap measures, mounted their main guns in hull sponsons rather than rotating turrets, a significant tactical limitation. American designers needed something better, something that could match German panzers while remaining practical to manufacture in enormous quantities. The result was the medium tank M4, which became known universally as the Sherman. Its design prioritized reliability, ease of manufacture, crew survivability, and firepower. The tank that emerged from this process was not the most heavily armored or the most powerfully gunned tank of the war. German Tigers and Panthers exceeded it in both categories. But the Sherman represented something more important than raw specifications. It embodied American, industrial philosophy. Build something good enough, build it reliably, and build overwhelming numbers of them. The Sherman's 75mm M3 gun was adapted from the French Canon de 75mm Model 1897, one of history's most successful artillery pieces. American engineers had modernized this design, creating a tank gun capable of firing armor-piercing, high-explosive, smoke, and canister rounds. The gun's performance against armor was respectable, though not exceptional by 1943 standards. It could penetrate approximately 3 inches of armor plate at 500 yards, sufficient against most German and all Japanese tanks it would encounter in the Pacific. But the gun's true revolutionary feature was not its penetrating power. It was its rate of fire. The M4 Sherman could sustain a firing rate of 8 to 10 aimed rounds per minute under combat conditions, with well-trained crews achieving even higher rates for brief periods. This capability derived from multiple design features working in concert. The gun's recoil system absorbed firing stresses efficiently, allowing rapid relaying of the gun on target. The turret's power traverse system enabled quick target tracking. But most critically, the ammunition, storage and loading system facilitated rapid sustained fire. Sherman ammunition was stored in racks throughout the hull and turret, positioned for quick access by the loader. Each round was separate from its propellant cartridge, allowing the loader to handle them efficiently in the confined space. The loader stood on the right side of the gun, with ammunition racks positioned within easy reach. A well-trained loader could maintain a rhythm: retrieve round, load, step back, gunfires, retrieve next round, 8 to 10 seconds per complete cycle. This rate of fire was not theoretical. American tank crews trained extensively in gunnery, and rapid sustained fire was a fundamental skill. Crews competed to see who could achieve the fastest times while maintaining accuracy. Training films emphasized that in tank combat, the crew that fired effectively first usually won, and the crew that could fire repeatedly while the enemy reloaded possessed overwhelming advantage. Japanese tankers had no equivalent training or capability. The Type 97 Shiha's 57mm gun was a low-velocity weapon optimized for high-explosive rounds against infantry and fortifications. Its armor-piercing capability was marginal even against lightly armored targets. But beyond the gun's limited power, the tank's entire design hindered rapid fire. The Shiha's turret was cramped, mounting only a two-man crew, commander and gunner. The loader worked from the hull, passing ammunition up through a small opening into the turret. This arrangement was awkward and slow. The ammunition itself was bulky and difficult to handle in the confined space. The gun's recoil system was basic, and the turret lacked power traverse, requiring manual cranking to rotate. Under ideal conditions, a well-trained crew might achieve 3 rounds per minute. Under combat stress, with the confusion of battle, this rate dropped significantly. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Japanese tank doctrine compounded these limitations. Tankers were taught to fire deliberately, taking time to aim carefully before each shot. This made sense given their guns' limited range and penetrating power. A Shiha could not afford to waste ammunition. Every shot needed to count. Japanese crews were also trained to position defensively, using camouflage and concealment rather than aggressive maneuver. The tank was viewed as a mobile pillbox, a platform for the gun rather than a maneuver element. These tactical principles had worked reasonably well against Chinese and British colonial forces. They would prove catastrophic against American armor. The first major tank engagement between Japanese and American forces occurred during the Guadalcanal campaign. On October 23, 1942, 9 Type 97 Shiha tanks advanced toward American positions near the Guadalcanal River. The Japanese attacked at night, hoping darkness would negate American advantages. They encountered a mixed defense of infantry anti-tank guns and several M3 Stuart light tanks. The engagement was brief and one-sided. American guns destroyed all 9 Japanese tanks within minutes. The Japanese tank crews, trained for infantry support operations, found themselves outmatched in a pure armor engagement. Their thin armor, 25mm at maximum thickness, could not withstand American 37mm anti-tank guns, much less the 75mm guns of arriving Sherman tanks. But this early engagement did not fully reveal the Sherman's capabilities. The fighting occurred at night at close range under confused conditions. Japanese survivors could attribute their defeat to American numerical superiority, better defensive positions, and perhaps inadequate reconnaissance. The fundamental technological gulf remained partially hidden. That changed as the campaign progressed, and both sides deployed more armor. American forces brought increasing numbers of Sherman tanks forward as logistics improved and more shipping became available. Japanese forces, reinforced with additional armor, prepared for more ambitious attacks. The commanders on both sides recognized that control of Guadalcanal's limited road network and airfields would require armored forces. The pivotal engagement occurred in November 1942 near Point Cruz. Japanese forces assembled a combined arms attack including infantry, artillery, and 9 Type 95 Hargo light tanks, supported by several Type 97 Shiha medium tanks. The assault aimed to recapture Henderson Field and drive American forces from the island. American defenders included Marine infantry, artillery, and a platoon of 4 M4 Sherman tanks from the 1st Marine Tank Battalion. The terrain funneled the attack into a relatively narrow front, negating Japanese numerical advantages and creating ideal conditions for defensive fire. The Japanese armor advanced in daylight, following the coastal road with infantry support on their flanks. American observers spotted the attack while the Japanese were still more than a mile distant, providing ample warning for defensive preparations. The Shermans positioned themselves in hull-down positions, with only their turrets visible over terrain features. This tactic maximized their armor protection while providing clear fields of fire across the Japanese approach route. As the range closed to approximately 1,000 yards, the Sherman platoon leader gave the order to commence firing. What followed was a masterclass in American gunnery doctrine. The 4 Shermans opened fire nearly simultaneously, each engaging a separate target. The Japanese tankers, still advancing and unprepared for contact at this range, had no time to react. The first salvo struck 3 Japanese tanks, 2 Hargo light tanks, and 1 Chiha medium. All 3 were penetrated and destroyed almost instantly. The remaining Japanese armor, confused by the sudden violence, attempted to deploy into combat formation and return fire. They never got the chance. The Sherman crews maintained steady, disciplined fire. Each tank commander directed his gunner to the next target as soon as the previous round impacted. Loaders worked with practiced efficiency, maintaining the rhythm of sustained fire. Within 2 minutes, all 9 Japanese light tanks were burning. The Chiha medium tanks, with slightly better armor and more experienced crews, survived marginally longer. One managed to fire a single round that struck a Sherman's frontal armor, bounced off harmlessly. The Chiha was destroyed seconds later by 3 separate 75mm rounds from different Shermans, an example of the Americans' overwhelming rate of fire. The entire engagement lasted less than 5 minutes. Every Japanese tank was destroyed or disabled. Not a single Sherman suffered serious damage, though 2 had taken hits that failed to penetrate their armor. The most significant aspect was not simply that the Americans won. It was the manner of their victory. Japanese survivors, infantry who had been advancing alongside the tanks, reported that American tanks seemed to fire continuously, with no perceptible pause between rounds. This was incomprehensible to soldiers whose experience with tank gunnery involved long pauses between shots. The psychological impact on Japanese forces was profound. Infantry, who had relied on armor support, now understood that their tanks were not just outmatched, they were obsolete. Tank crews who survived the engagement faced an existential crisis of confidence. Everything they had been taught about armored warfare had proven wrong. Their training, their tactics, their equipment, all were inadequate against this American machine that fired impossibly fast and shrugged off their return fire. Japanese military intelligence gathered reports from survivors and attempted to understand what had happened. Initial assessments suggested that Americans must have deployed multiple tanks in close formation, creating the illusion of rapid fire from a single vehicle. This theory collapsed when interrogators spoke with survivors who had clear sightlines to individual American tanks and could confirm that single vehicles were indeed firing at the reported rates. Other theories emerged. Perhaps the Americans had developed an automatic loading system, some mechanical device that eliminated the human loader. Perhaps they used smaller, lighter ammunition that could be handled more quickly. Perhaps their guns had multiple barrels that fired in sequence. Each theory, when examined against available evidence, proved incorrect. The truth was simultaneously simpler and more disturbing than these theories suggested. Americans had not invented revolutionary new technology. They had simply engineered every aspect of their tank to work efficiently, trained their crews to exceptional standards, and created doctrine that exploited these advantages ruthlessly. The result was a weapons system that operated at a tempo Japanese forces could not match. As the war progressed through 1943 and into 1944, this pattern repeated itself across the Pacific. At Tarawa, Makin, Kwajalein, Saipan, Guam, and Peleliu, wherever Japanese armor appeared, American Shermans destroyed it with methodical efficiency. The outcomes were so consistent that American tank crews began to view Japanese armor as target practice rather than serious threats. Japanese military leadership faced a dilemma that went beyond simple tactical adjustments. The problem was not merely that American tanks were superior, though they clearly were. The deeper issue was that Japan's entire approach to armored warfare had been rendered obsolete, and the industrial capacity to rectify this situation did not exist. Understanding this reality required examining not just individual tank engagements, but the broader context of Japanese tank development and the assumptions that guided it. Japan's tank program had originated in the 1920s, influenced heavily by British and French designs from the First World War. The Imperial Japanese Army purchased several Renault FT-17 light tanks and used them as templates for domestic development. This made sense at the time. European powers led the world in armoured warfare doctrine, and Japan sought to modernize its military along Western lines. The resulting Type 89 medium tank, introduced in 1929, was a respectable design by the standards of its era. It featured a 57mm gun, armour up to 17mm thick, and a top speed of 15 miles per hour. Against the Chinese forces, Japan anticipated fighting. This was adequate. Throughout the 1930s, Japanese tank development remained focused on the China theatre. The Type 95 Hugo light tank, introduced in 1935, and the Type 97 Chi-Ha medium tank, introduced in 1937, were both designed primarily for operations in Manchuria and China proper. The terrain, the expected opposition, and the logistical constraints of operating on the Asian mainland all shaped these designs. Speed and mechanical reliability mattered more than heavy armour or powerful guns. The enemy possessed limited anti-tank capabilities, making thick armour unnecessary and wasteful of scarce resources. This design philosophy delivered results in China. Japanese armour performed well in the Second Sino-Japanese War, supporting infantry advances and exploiting breakthroughs with rapid movement. The tank's shortcomings were not apparent because Chinese forces lacked effective counters. When war expanded to Southeast Asia in 1941, Japanese armour again performed adequately. British and Dutch colonial forces in Malaya, Singapore, and the Dutch East Indies were unprepared for jungle warfare and possessed minimal armour of their own. Japanese tanks, operating in terrain that should have negated their advantages, nevertheless contributed significantly to rapid Allied defeats. Once again, Japanese tank doctrine appeared validated. The tanks were doing what they were designed to do, supporting infantry, exploiting breakthroughs, and providing mobile firepower against enemy positions. That these positions were defended by troops with inadequate anti-tank weapons was a detail that did not immediately register as problematic. The fundamental miscalculation was assuming that future opponents would resemble past ones. Japanese planners had optimized their armor for wars already fought, rather than wars they might face. When American forces entered the Pacific theater with modern equipment and doctrine specifically developed to counter advanced opponents, this miscalculation became catastrophic. The Americans had studied German armored operations in Europe, incorporating lessons from the fall of France, Operation Barbarossa, and the North African campaigns. They understood that modern armoured warfare required tanks capable of sustained combat against enemy armour, not merely infantry support vehicles with guns. American tank development reflected this understanding at every level. The Sherman's design prioritized crew survivability through multiple features. The hull was spacious by tank standards, allowing crew members to work efficiently without excessive cramping. 5 men operated the tank: commander, gunner, loader, driver, and assistant driver, who also served as hull machine gunner. This division of labor meant each crew member could focus on specific tasks rather than juggling multiple responsibilities. The commander, positioned in the turret with excellent visibility through a rotating cupola, could focus entirely on tactical decisions, identifying targets, directing the gunner, communicating with other tanks and supporting units, and maintaining situational awareness. He was not burdened with loading ammunition or manually traversing the turret. The gunner operated the main gun and coaxial machine gun, focusing on accurate fire. The turret's power traverse system, driven by hydraulics or electric motors depending on the Sherman variant, allowed rapid target tracking without exhausting physical effort. The gunner used an M4 periscope sight with magnification, providing clear target identification at combat ranges. The sight incorporated a simple but effective ranging reticle that, when used properly, enabled accurate first-round hits. The loader's position maximized efficiency. Ammunition racks surrounded his station, positioned for quick access with minimal movement. The racks themselves were designed to hold rounds securely during movement while allowing rapid extraction. Different types of ammunition, armor-piercing, high-explosive, smoke, were stored in designated racks and clearly marked, preventing confusion during combat. A well-trained loader developed a rhythm that became almost automatic. As the gun fired and recoiled, he was already reaching for the next round. His hands found the ammunition by feel, muscle memory from countless training repetitions. He loaded, stepped clear, braced for recoil, and reached for the next round before the spent shell casing finished ejecting. 8 to 10 seconds per cycle was not the theoretical maximum. It was the sustainable combat rate that good crews maintained for extended periods. This capability was not accidental. American training doctrine emphasized gunnery above nearly all other tank skills. Crews spent weeks at gunnery ranges firing hundreds of practice rounds before being considered combat ready. They practiced engaging stationary targets, moving targets, targets at various ranges, and rapid engagement of multiple sequential targets. Training scenarios deliberately stressed crews, requiring them to maintain their firing rhythm while dealing with simulated mechanical failures, casualties, or communications breakdowns. The goal was creating muscle memory so ingrained that crews could maintain effective fire even under the chaos and terror of actual combat. Instructors emphasized that combat was won by the side that fired effectively first and then continued firing while the enemy struggled to respond. A Sherman crew that landed its first hit and then put 2 or 3 more rounds into the target before the enemy could return fire had essentially guaranteed victory. Japanese training provided no equivalent preparation. Tank crews received basic instruction in operating their vehicles and firing the main gun, but sustained gunnery training was minimal. Ammunition was expensive and scarce, limiting practice opportunities. Crews might fire a handful of live rounds during training before being declared operational. This meant that many Japanese tankers entered combat never having experienced the stress of sustained firing, the fatigue of repeated loading cycles, or the discipline required to maintain accurate fire under pressure. The first time they attempted rapid, sustained fire was often during actual combat, with predictable results. Japanese tank commanders also labored under doctrine that distributed responsibilities differently. The Type 97 Chaiha's 2-man turret crew meant the commander often served as gunner, dividing his attention between tactical decisions and actually firing the weapon. This arrangement was common in many nations' tanks during the interwar period, but more advanced designs had moved to 3-man turrets specifically to separate these functions. A commander who was also aiming and firing the gun could not effectively command his tank, communicate with other units, or maintain situational awareness. The physical layout of Japanese tanks compounded these issues. Turrets were cramped, with limited space for crew movement. Ammunition storage was often poorly positioned, requiring the loader to contort awkwardly to access rounds. Vision devices were minimal, leaving commanders with restricted views of their surroundings. Radio equipment, when present at all, was often unreliable and short-ranged. Many Japanese tanks carried no radios whatsoever, relying on flag signals or pre-arranged maneuvers for coordination. These limitations meant that even when Japanese tank platoons outnumbered their American opponents, they could not coordinate effectively. Each tank fought essentially alone, unable to concentrate fire or execute complex tactical maneuvers. American tank platoons, by contrast, operated with sophisticated radio coordination. Every tank carried at least one radio, usually two, an intercom system for internal crew communication, and an external radio for communication between tanks and with higher headquarters. This allowed Sherman platoons to fight as integrated teams, concentrating fire on priority targets and supporting each other with coordinated movement and overwatch positions. The tactical implications were profound. A single platoon of 4 Shermans, working together with radio coordination, could defeat significantly larger Japanese forces through superior cooperation and fire concentration. American doctrine emphasized these combined arms tactics, teaching tank commanders to work with infantry, artillery, and air support in integrated teams. Japanese doctrine, by contrast, tended to employ armor in isolation or with minimal coordination with other arms. The captured Sherman that Japanese forces eventually recovered intact came from fighting on Saipan in June and July of 1944. The circumstances of its capture reflected the desperate nature of Japanese defensive operations by this stage of the war. American forces had landed on Saipan on June 15, 1944, beginning a brutal month-long campaign for the island. The terrain was challenging. Volcanic rock, steep ravines, dense vegetation, and fortified positions. Japanese defenders numbered over 30,000 troops, including substantial artillery and a small number of tanks. The Americans committed overwhelming force: 2 Marine divisions, 1 Army division, and massive naval and air support. Among the American armor deployed were companies from the 2nd and 4th Marine Tank Battalions, equipped with M4A2 Sherman tanks mounting the standard 75mm gun. The fighting was intense and costly. Japanese forces, knowing they could not win, were determined to extract maximum casualties from the attackers. They employed a defense in depth, forcing Americans to assault one fortified position after another. Tank versus tank engagements were rare, most Japanese armor having been destroyed in the opening days of the battle. But on June 26, 1944, during fighting for the Kagman Peninsula, a Sherman from Company A, 2nd Tank Battalion, advanced too far beyond supporting infantry and drove into a camouflaged ravine. The tank bellied out on volcanic rock, becoming stuck. Before the crew could extract the vehicle, Japanese infantry counterattacked, forcing the tankers to abandon their Sherman and withdraw to American lines. Japanese forces swarmed over the captured tank, initially attempting to destroy it with explosives. An officer intervened, recognizing the intelligence value of an intact American tank. Working under cover of darkness, Japanese engineers managed to free the stuck Sherman and tow it to a concealed position using a Type 95 Hargo tank as a tractor. The Sherman was then carefully camouflaged and guarded, while arrangements were made to transport it to Japan for technical analysis. The tank never reached Japan. American forces overran the Japanese positions during the final stages of the Saipan campaign, and the Sherman was recovered by its original unit. But during the brief period, Japanese forces held the tank. Technical personnel conducted preliminary examinations, and officers questioned captured American tankers about the Sherman's capabilities and employment. These examinations and interrogations produced reports that circulated within Japanese military intelligence circles, reaching armor specialists who had been struggling to understand American tank capabilities. What Japanese engineers found during their hurried examination of the Saipan Sherman confirmed and expanded upon lessons from combat reports. The tank's construction quality impressed them immediately. The hull was welded rather than riveted, with welds of consistently high quality. The armor plate showed uniform thickness and composition, indicating sophisticated steel production. The thickness was not exceptional by German or Soviet standards. The Sherman's frontal armor was approximately 50 millimeters, about 2 inches, but the quality of the steel and the shaping of the armor provided effective protection against Japanese anti-tank weapons. The turret drew particular attention. Its size allowed 3 crew members to work efficiently, a luxury Japanese tank designers had never seriously considered. The power traverse system, operated by hydraulic pressure from an engine-driven pump, could rotate the turret 360 degrees in less than 15 seconds. Japanese turrets, hand-cranked by the gunner, required laborious manual effort and much longer rotation times. This single feature gave American tanks enormous advantages in rapidly engaging multiple targets or tracking moving targets. The gun itself fascinated Japanese examiners. The 75mm M3 gun was not particularly large by 1944 standards. German Panthers mounted 75mm guns with much higher muzzle velocities, and Tigers carried 88mm guns that outclassed anything the Allies fielded. But the M3's design embodied different priorities. It was not designed to penetrate heavy German armor at long range, though it was adequate for most encounters. Instead, it was optimized for reliability, ease of maintenance, and rapid sustained fire. The recoil mechanism was robust and simple, requiring minimal maintenance. The breech block operated smoothly with a semi-automatic mechanism that ejected spent casings and recocked the firing mechanism automatically. This eliminated several manual steps that Japanese guns required, directly contributing to faster firing rates. The ammunition storage arrangements showed sophisticated design thinking. Ready racks in the turret held 18 rounds, immediately accessible to the loader. Additional ammunition, totaling 71 to 97 rounds depending on Sherman variant, was stored throughout the hull in positions that balanced weight distribution while remaining reasonably accessible. The ammunition itself revealed American manufacturing capabilities. Each 75mm round was precisely manufactured to tight tolerances. The brass cartridge cases were uniform, the projectiles were accurately dimensioned, and the propellant charges were consistent. This precision meant that guns could be accurately zeroed and would maintain that zero across multiple rounds. Japanese ammunition, increasingly produced under wartime stress with substitute materials and less skilled labor, showed much greater variation. Guns might require re-zeroing after firing only a few rounds due to ammunition inconsistency. Japanese examiners noted the Sherman's vision devices, including periscopes for the driver and assistant driver, the commander's rotating cupola with vision blocks, and the gunner's telescopic sight. These devices were well designed and manufactured from high-quality optical glass. Japanese tank vision devices, by contrast, were often crude and limited in field of view. The Sherman's crew could maintain much better situational awareness, seeing threats and targets that Japanese crews might miss entirely. The engine compartment revealed the Continental R975 radial aircraft engine that powered most Sherman variants. This air-cooled 9-cylinder radial produced 400 horsepower, giving the 30-ton Sherman a power-to-weight ratio superior to most Japanese tanks. The engine's reliability was legendary. American power plants routinely operated for hundreds of hours between major maintenance, while Japanese tank engines frequently required attention after only dozens of hours. This reliability gap meant American tanks were available for operations far more consistently than their Japanese counterparts. Perhaps most impressive to Japanese engineers was the overall systems integration. Every component seemed designed to work harmoniously with every other component. The engine powered hydraulic systems for turret traverse and gun stabilization. The electrical system powered radios, turret rotation, gun stabilization, and interior lighting. The suspension system, while not sophisticated by German standards, was reliable and provided a stable firing platform. Everything worked together to create a weapon system greater than the sum of its parts. Japanese military leadership understood that the Sherman represented more than superior engineering. It symbolized an entire industrial philosophy that Japan could not replicate. American factories produced Shermans by the tens of thousands, 49,234 units during the war years, while Japanese industry struggled to manufacture even a few thousand tanks total across all types. The disparity was not merely quantitative. American production maintained consistent quality across this enormous output, while Japanese production quality deteriorated as the war progressed and resources grew scarce. The Sherman's design facilitated mass production through deliberate engineering choices. Components were standardized wherever possible, allowing multiple manufacturers to produce parts that would fit any Sherman, regardless of which factory assembled the final tank. The hull used large welded sections rather than hundreds of individual rivets, reducing assembly time and labor requirements. The suspension system, while mechanically simple, used commercially available components adapted from agricultural and industrial machinery. This pragmatic approach meant that repair parts could be manufactured by facilities throughout American industry, not just specialized military contractors. Japanese tank production operated under entirely different constraints. Factories were smaller and less mechanized. Skilled labor was increasingly scarce as workers were conscripted for military service. Raw materials, especially high-quality steel and aluminum, were in chronic short supply. The result was that even when Japanese engineers designed improved tanks, production rarely matched the prototype's theoretical capabilities. The Type 3 Chi-Nu medium tank, introduced in 1944 with a more powerful 75mm gun specifically to counter American armor, was produced in quantities too small to affect the war's outcome. Only 166 units were completed before war's end, and most never saw combat. This production inadequacy reflected deeper problems in Japanese industrial organization. American industry operated on principles of standardization, interchangeable parts, and assembly line production perfected by automotive manufacturers like Ford and General Motors. These companies transitioned to tank production, bringing their mass production expertise with them. Fisher Body Division, a General Motors subsidiary that normally produced automobile bodies, became one of the largest Sherman manufacturers. The company applied automotive production techniques to tank manufacturing, achieving output rates that would have seemed impossible using traditional methods. Japanese industry lacked this manufacturing culture. Production remained more artisanal, with skilled craftsmen building vehicles almost individually. Quality depended heavily on the skill of particular workers, rather than on systematic processes that guaranteed consistent results regardless of who performed the work. As the war consumed Japan's skilled workforce, this approach became increasingly untenable. Tanks rolled out of factories with defects that would never have passed American quality control inspections. Engines failed prematurely, transmissions broke down, armor plate varied in thickness and hardness, and guns showed inconsistent accuracy. The capture Sherman's examination also revealed American approaches to crew survivability that contrasted sharply with Japanese design philosophy. American tankers fought in vehicles designed with their survival as a priority. The spacious interior allowed crew members to move and escape if necessary. 5 separate hatches provided multiple escape routes. The driver and assistant driver each had hull hatches. The commander and loader each had turret hatches, and the loader's hatch was large enough to permit rapid emergency exit. Fire suppression systems included carbon dioxide extinguishers and, in later models, automatic fire suppression in the engine compartment. Japanese tanks, by contrast, provided minimal consideration for crew survival. Interiors were cramped, making escape difficult under the best circumstances, and nearly impossible if the tank was damaged or on fire. Hatches were few and small, often requiring crew members to contort awkwardly to exit. Fire suppression systems were basic, or non-existent. When Japanese tanks were hit and caught fire, crew survival rates were appallingly low. American tankers, though they certainly faced dangers, had significantly better chances of surviving their tank being knocked out. This difference reflected fundamentally different attitudes toward human resources. American military doctrine treated trained crews as valuable assets worth protecting. Losing a tank was acceptable if the crew survived to fight another day in a replacement vehicle. Japanese doctrine, influenced by cultural factors emphasizing sacrifice and group obligation over individual survival, did not prioritize crew protection to the same degree. The result was that experienced Japanese tank crews were systematically attrited away, even when tanks themselves might have been replaceable. By 1944 and 1945, many Japanese tanks were crewed by inadequately trained replacements who lacked the experience to employ even their inferior vehicles effectively. The psychological dimension of facing Shermans in combat cannot be overstated. Japanese tank crews went into battle knowing they were outmatched. They had heard the stories from survivors, had read the after-action reports, and understood the statistical reality. Engaging an American tank was likely to result in death. This knowledge affected morale and tactical decision-making in ways that are difficult to quantify but were certainly significant. Some crews fought with fatalistic courage, others sought to avoid engagement when possible, and many simply froze when confronted with Shermans, unable to execute even basic combat drills under the stress of facing overwhelming technological superiority. American tankers, by contrast, operated with confidence bordering on complacency when facing Japanese armor. Intelligence briefings made clear that Japanese tanks were not serious threats. American crews were warned to remain alert for Japanese infantry anti-tank tactics, which were often suicidally brave and sometimes effective. But tank versus tank engagements were not considered particularly dangerous. This confidence allowed American crews to take tactical risks and operate aggressively, knowing their armor protection and firepower provided substantial margins for error. The comparative ease with which Shermans defeated Japanese armor freed American commanders to employ tanks in broader roles. Rather than husbanding armor for specific anti-tank missions, commanders could use Shermans liberally for infantry support, bunker reduction, and fire support. The tank's versatility meant it appeared throughout American operations in the Pacific. During amphibious landings, Shermans often came ashore on the first or second wave, providing immediate heavy fire support for infantry struggling to establish beachheads. The tanks proved invaluable for reducing Japanese fortified positions. Their 75mm guns could fire high-explosive rounds directly into bunker apertures, and their armor protected them from most Japanese defensive fire. Tank infantry cooperation became highly refined. Marines and Army infantry learned to work closely with Sherman platoons, using infantry to protect tanks from close-range anti-tank attacks, while tanks suppressed enemy positions threatening the infantry. This combined arms approach maximized the effectiveness of both elements. Japanese defenders developed considerable respect for American tank infantry teams, recognizing that defeating them required separating the tanks from their infantry support and then engaging the isolated armor with close-range anti-tank weapons. Even this desperate expedient rarely succeeded. American infantry were trained to maintain close contact with supporting tanks, and American tanks were trained to remain aware of infantry positions and provide covering fire. Breaking up these teams required Japanese forces to accept catastrophic casualties, and even successful attacks often only temporarily disrupted American advances before replacement tanks and infantry reconstituted the assault. As the war moved closer to Japan itself, the defensive situation grew increasingly desperate. The fall of Saipan in July 1944 brought the Japanese home islands within range of American B-29 bombers. The loss of the Philippines between October 1944 and July 1945 severed Japan's access to resource-rich Southeast Asia. The February 1945 invasion of Iwo Jima and the April invasion of Okinawa demonstrated that Americans were willing to pay heavy costs to seize islands that could support the eventual invasion of Japan proper. Japanese military planners understood that the final battle for the home islands was approaching and that American armor would play a major role in that invasion. Defensive preparations focused on creating fortified positions that might delay or channel American armor into killing zones where massed anti-tank guns and suicide attackers could engage them. The plan, designated Operation Ketsugo, called for concentrating remaining Japanese forces to defend the home islands with fanatical determination. Every available weapon would be employed, including thousands of aircraft reserved for kamikaze attacks, millions of infantry armed with whatever weapons could be produced or improvised, and the remnants of Japanese armored forces. Japanese tank units were reorganized and re-equipped as much as limited resources permitted. Priority went to defending the Kanto Plain around Tokyo, where American forces were expected to land. Tank battalions received what new equipment was available, mostly Type 3 Chi-Nu medium tanks and Type 4 Chi-2 medium tanks. The Chi-2 mounted a more powerful 75mm gun with higher muzzle velocity, theoretically capable of penetrating Sherman armor at combat ranges. But production numbers were minuscule, only 2. Prototype Chi-2 tanks were completed before war's end. The units that would face American invasion forces would do so primarily in obsolete Type 97 Chi-Ha tanks, supplemented by whatever else could be scraped together. Training for the final battle emphasized defensive tactics designed to maximize whatever advantages terrain and preparation might provide. Tank crews were taught to fight from concealed, fortified positions rather than mobile engagement. The plan was to allow American armor to advance past initial defensive lines, then engage from the flanks and rear using terrain for cover. Tanks would be dug in as stationary gun positions, surrendering mobility in exchange for better protection and concealment. This was an implicit admission that Japanese armor could not face American tanks in open mobile combat. The only hope was to negate American advantages through careful positioning and accepting that Japanese tanks would essentially serve as poorly protected but mobile bunkers. Japanese tankers training for this mission understood the likely outcome. They were being prepared for suicide missions, expected to destroy perhaps 1 or 2 American tanks before being destroyed themselves. The emphasis in training shifted from tactical skill to psychological preparation for certain death. Instructors reminded crews of their duty to emperor and nation, encouraged them to view their sacrifice as honorable, and taught them to maximize damage inflicted before their inevitable destruction. The atomic bombings of Hiroshima on August 6, 1945, and Nagasaki on August 9, followed by the Soviet Union's declaration of war and rapid invasion of Manchuria, rendered these desperate defensive preparations moot. Emperor Hirohito announced Japan's surrender on August 15, 1945, ending the war before Operation Ketsugo could be tested. The planned final battle never occurred, and Japanese tank crews never had to execute their reserves. Suicide missions defending the home islands. American occupation forces arriving in Japan found stockpiles of weapons prepared for that final defense, including hundreds of tanks positioned around potential invasion beaches and prepared defensive positions throughout the Kanto Plain. The examination of these Japanese defensive preparations revealed the extent to which Japanese military planners understood their armored forces' obsolescence. The tactics devised for defending Japan were not designed to win battles but to inflict casualties and delay inevitable defeat. Japanese tanks would have been sacrificed in static defensive positions because that was the only employment that offered even marginal effectiveness against American armor. The contrast between this defensive desperation and the confident mobile operations of American armored forces illustrated the technological and doctrinal chasm that had opened during the war years. In the post-war period, American and Allied investigators conducted extensive assessments of Japanese military capabilities, including detailed examinations of Japanese armor. Technical intelligence teams measured, photographed, and tested surviving examples of Japanese tanks. The reports they produced documented the vast qualitative gap between Japanese and American armored fighting vehicles. These assessments noted that even Japan's most modern tanks, the types that saw limited production in 1944 and 1945, would have been considered obsolete by American standards. The investigators also examined Japanese tank production facilities, finding factories that were primitive by American standards and had been further degraded by bombing. Japanese engineers and designers, questioned by American technical teams, acknowledged that they had understood their tanks were inferior, but lacked the industrial capacity and resources to close the gap. Some expressed admiration for American engineering and manufacturing techniques, recognizing that the Sherman represented an achievement Japanese industry could not have replicated even under peacetime conditions. The lessons learned from Pacific tank warfare influenced American armor development in the immediate post-war years, though perhaps not as dramatically as might be expected. The Sherman had proven effective against Japanese armor and adequate for infantry support, but combat in Europe against German tanks had revealed its limitations against heavier, more powerfully armed opponents. Post-war American tank development focused on addressing European lessons rather than Pacific ones, leading to new designs like the M26 Pershing heavy tank and eventually the M48 Patton series. For Japan, the war's end brought complete disarmament under occupation authority. The Japanese military was disbanded, and weapons production ceased entirely. When Japan eventually rebuilt its self-defense forces in the 1950s, armored units were initially equipped with American tanks provided under military assistance programs. Japanese defense industries, rebuilt under American guidance, eventually developed domestic armored vehicles, but these were designed for defensive operations on Japanese terrain rather than offensive armored warfare. The story of Japanese forces confronting the M4 Sherman stands as a testament to the decisive role industrial capacity and technological sophistication play in modern warfare. Japanese tankers were not lacking in courage or determination. They fought with the equipment and training they had been given, often displaying remarkable bravery in hopeless situations. But courage alone could not overcome the fundamental realities of the Sherman's superiority in firepower, protection, reliability, and crew ergonomics. The tank that Japanese gunners refused to believe could fire so rapidly was not a miracle weapon or secret technology. It was simply a well-engineered machine, produced by an industrial system capable of translating design requirements into mass-produced reality. The rapid rate of fire that so astonished Japanese tankers came from careful attention to details, ammunition positioning, turret layout, recoil systems, and crew training. Every aspect of the Sherman's design reflected a holistic approach to creating an effective weapons system. Japanese examination of captured Shermans revealed these truths, but understanding the problem did not provide solutions Japan's wartime economy could implement. The industrial and resource gap was simply too vast to bridge through engineering ingenuity alone. The encounter between Japanese armor and the Sherman thus became a microcosm of the larger Pacific War, a conflict in which determination and tactical skill could not overcome overwhelming material superiority. The lessons echo beyond their immediate historical context. They remind us that technological competition between nations is fundamentally about industrial capacity, resource access, and the ability to translate scientific knowledge into practical applications. Japan's failure to match American tank capabilities was not primarily a failure of intelligence or effort. It was the inevitable result of challenging an opponent whose industrial base was larger, more sophisticated, and better resourced. For the Japanese tankers who faced Shermans in combat, these broader strategic realities mattered less than immediate survival. They fought in tanks they knew were inferior, firing guns that could not penetrate enemy armor at ranges where enemy guns could destroy them. That they fought at all under these circumstances speaks to human courage and duty. That they lost so consistently speaks to the cold calculus of technological warfare, where the side with better equipment, better training, and overwhelming numbers wins regardless of individual valor. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.